Hi everyone, thank you for joining us. Today we're going to be talking about real-time intelligence and building event-driven apps and agents. My name is Tessa Kloster. I'm a partner director of product management for real-time intelligence and IQ, and I'm joined with my friends and colleagues, Arindam and Anshul, that will tell you more about the different parts of the system, as well as actually doing some live demos. So let's jump in. Everyone, of course, talks about AI, but why does it really matter for your organization, and how can you use it to unlock real value? The reality is that AI really excels at, specific things, really being able to find all of these different signals that matter and helping you understand and distill and really make good decisions in time through all of this noise of information. Because the reality is a lot gets in the way today. The data volumes are too large. There's too many instances for like an individual human to understand. Even if we are able to distill it and understand it, sometimes we aren't able to actually act in time to have a positive outcome. And so all of this leaves a lot of opportunity for a system to help, and especially in the era of AI. But it needs more kind of structure and layers to really have that operational foundation for the modern enterprise. So if you think about all the signals and coming in and all the actions feeding back into that system, we really need to have the different layers, whether it's the unified data estate, really making sense of it with a unified data platform, and building on top of it with a unified intelligence platform to really ensure that the entire team, both humans and agents, are able to get the best and most out of the system and be able to act in the right time. And this is where Microsoft Fabric comes in. So Microsoft Fabric is that unified data platform for the AI transformation. And hopefully, as you know, we have a wide range of capabilities that span, data integration, big data analytics, out-of-box databases, real-time intelligence, which is what we're going to talk about today, the IQ capabilities, which we announced back at Ignite, as well as, of course, Power BI. And all of this is built on top of that unified Fabric platform that has one lake, shared governance, and, of course, Copilot integrated throughout. So if I look specifically at real-time intelligence, what we were able to do is take, the enterprise real-time data platforms that we have, whether it's Azure Event Hubs, Event Grid, Stream Analytics, Data Explorer, Azure Maps, and marry it with the self-service experience that are more tailored for those business users. And as you'll see in some of the demos, there's a wide range of capabilities that are available. But if you think about the democratization of some of these really very technical and high-end systems and make them available to users of all different types. And of course, if you integrate the intelligent capabilities, whether it's AI skills, agents, all of this together provides a fully integrated SaaS experience where we can offer real-time intelligence directly natively in Microsoft Fabric. So what is real-time intelligence? Well, when we talk about it, it's actually a number of different capabilities. And of course, we always start with the data. So on the left-hand side here, you see the wide range of different out-of-box connectors we provide, whether it's for Microsoft sources or cross-cloud. And this makes it very easy. Wherever your streaming and event data is coming from, you can get it directly into the system. And we'll tell you more about that in the next sections. And as that data flows in, you can really leverage it in a number of different ways across the system. And when I say a number of different ways, we really do have different tools in the toolbox that you can use to ensure that you are able to get the most out of that data as it's flowing in, whether it's streaming and you want to process and transform it, route it in real time. We have a full, rich analytics capabilities that's curated for this time series data. We have modeling capabilities, whether it's with geospatial or the kind of relationship causals with graph, being able to visualize it in a truly real-time and operational way. And last but not least, really being able to actually act on it, make sense of it, and change the business and the systems around it to ensure that the business is able to keep up at the speed of data. So all of this together has all the different capabilities of real-time intelligence, and we really are seeing customers across the entire different industries, all these different verticals you see here, whether it's healthcare, sports, manufacturing, financial, retail, all of these different businesses and verticals need to improve their businesses and their operations, to mitigate risk, to improve efficiency, and real-time intelligence is helping them do that today. So with that, I'm going to hand over to Arindam, who's going to tell us a little bit more about that ingesting and processing part of real-time intelligence and get started with the demo. And I'll hand it to you, Arindam.
Thank you, Tessa. So I'm Aritham Chatterjee. I'm a Principal Product Manager on the Fabric Real-Time Intelligence team. And in the next few minutes, I'm going to talk to you about how you can ingest, process, and route the events in real time into Fabric. So as Tessa mentioned in her section, we get a lot of different sources that you can actually ingest your data from. We recognize that a lot of your data actually starts outside of Fabric. They are real-time in nature. And while you could write a lot of code to get the data in, we provide a managed experience through a whole bunch of connectors. It's close to 40 of them now that you can start with simple click and drag and drop experiences to get your connectors into your system and then use them to ingest the data. So from all those different sources, you're going to route the messages are going to get routed to an event stream, which actually exposes both a Kafka and AMQP endpoints. So a lot of flexibility there, whether you have got open source clients or you're using AMQP. Once the data is ingested, then you've got a couple of different ways to process the events while they are in motion. If you're familiar with SQL, then we have a SQL way of querying and transforming and processing that data. Or you could even opt for a no-code experience, which is, again, just a simple drag and drop of different operators onto a surface to process. Now, as the events are going in, they have a structure. They transform, they change shape. All of those can be registered into a schema registry and then managed from there. It provides you the governance capabilities as the data is moving through your system. But then once you're done processing and transforming your events, where does it go next? So you have a bunch of choices, including Event House, which is our high performance, low latency, high volume database for time series data. And Anshul will talk about that a lot more in detail. Once the data is in Event House, you can do your analytics. But it also provides, Event Stream also provides a way to integrate the output of your stream processing with other systems. For example, you can actually send it to another Kafka endpoint if that's what your application requires. Now, you can also act on the data, and this is where you can set up rules and use Activator to act and integrate with other systems as well. But last but not the least, I want to talk about Spark. As the data is coming in and you have your code, stream processing code, all in Spark, particularly in Python, then you can actually use Fabric Spark and Fabric Notebooks to pull the data from event stream, process it, and send it to further downstream endpoints that Spark can actually talk to. So that's the end-to-end. But this is all high-level picture. Let's see how it all comes together in a short demo. So all of us have been, to a stadium for concerts, for games. Next month we are going to have, a whole bunch of soccer games around the country, around the continent actually. And while we as fans go to the stadium and expect to have a good time, there's a lot going on in that stadium, and so as fans are coming in, as they are going through the turnstiles, they're purchasing concessions from the concession stands and enjoying the game. There are lots of different points where data is going to get generated, and so hundreds of different points from where data is generated, but also thousands of events that are actually happening every single second. And the challenge that the game day operations people have at the stadium is how to collect all of that data, make sense of that data, and be able to take action, within minutes, if not sometimes in seconds. So that's what I will walk you through, how to accomplish that with RTI and with event streams. All right, so let me show you what the developer journey now looks like. So I'm going to start in the real-time hub, which shows me all the different streaming assets that I have. So I'm going to go to the Add Data section, and you can see the dozens of connectors that we already have made available. In this case, I'm going to pick the MQTT connector. As from my turnstile, MQTT is a great protocol for getting events from my turnstile. So I'm just going to set up a secure connection to the broker, MQTT broker. And then I'm going to set up the topic name and then choose the MQTT version, in this case v3, which is very widely used in the IoT circles. I'm going to quickly review what the connection details are, and that's it. In just a few simple clicks, I now have an event stream that is actually ingesting data from all my turnstiles. So next up, I'm going to go and process that event. So I'm going to go and do it edit mode, launch the SQL code operator that I mentioned earlier, and then start writing the code. So you can see the edit query. It starts you off with a very simple select star query that I can actually now start to edit. I've written some code already, maybe with some agents. I'm going to move that here, and you can start to see that I can do, again, using very familiar SQL syntax, start to write the query, do some simple filtering and route to different destinations there. Now, one important thing here, without having to move to production, I can actually test the query from the editor itself, which is a great help and makes things a lot more productive as you're developing your complex jobs that you might have in your environment. So I'm going to go ahead and save. I like what I see here, so I'm going to save the query and publish the event stream. And so now the event stream is actually live. It is getting the events, it's getting processed and getting delivered into the event house destinations that I've set up. So let me go ahead and open the event house, and I can verify that all the turnstile passage events are showing up as I expected. So great. So now I'm going to go back, and then I'm going to see the next step. Now, in a complex environment, when you actual game day operations, lots of things happen. Events arrive late, they arrive out of order, and you need to handle those situations. So with event streams, we have actually made it very simple on just set up a few simple policies, and it will guide how event stream deals with the events that might show up late or out of order. So now I'm going to go into my event stream again and do something more interesting, which is actually try to detect duplicate tickets being used. That's fraud. With very simple window aggregations, this time I'm actually using a hopping window that within 120 seconds, if the same ticket gets used in different gates or even at the same gate, then that's something that event stream will be able to detect and warn you about. So that's it. I've set up my second SQL code operator, which can detect very simple fraud and alert me in a very short amount of time. So now I'm going to just go and set the alert. I'm going to bring up the activator UI, and each time that a fraud or duplicate ticket gets used, I'm going to go ahead and take some custom action, which in this case is just alert my operation staff to take some action. So with just a few simple clicks, you can see what kind of powerful insights you can get from your turnstile events and take some quick action as well. Now let's do a quick recap of what you just saw. I walked you through MQTT as an example, but it's amongst dozens of different connectors. This list keeps growing all the time. I want to call out the MQTT version that we just launched. Oracle DB Change Data connector is also available now. HTTP, which is you can actually go to REST endpoints and grab data from there automatically. That's very popular amongst our customers. And then MirrorDB Change Feed Connector, another one that we are launching to help you get change data feeds from databases, from Delta tables and mirror databases. But we also have a series of connectors that are on deck, and they will be available very soon. And please let us know if there is something that is missing that we'll add. But one as developers out here, we don't want to be stuck necessarily behind somebody providing connectors. We sometimes have our own connectors. We have our own data sources. And so I'm very happy to announce that we have a custom stream connector, which is currently in private preview, where you can create your own connector, upload the package, and we will host that connector for you and to get data from your sources into an event stream. I already mentioned event stream. Just a quick recap there. It lets you use powerful SQL semantics, including joins, window functions, which are particularly useful for stream processing. The same SQL query or a SQL operator can now write to multiple destinations. So whether it's you send it to an event house or directly to an activator, all of those are supported. I mentioned complex event time handling policies. These are particularly useful when you are in production and you expect sometimes things not to go according to plan. And last but not the least, for developers, the productivity features around interactive preview, testing, and debugging. So all of that, and there's a lot more that is coming down the pipe. So please give it a try and let us know what you think. All right, so now let's go to the next part of our demo. So in this, we are going to use a different set of sources and do some processing there with Spark. So let's see. Okay, so I'm going to go now. Our game day participants that have shown up, the fans have shown up, but now they're going to the concession stands and buying things. And now I need to track, make sure that the inventory is always there. So I'm going to create another event stream. This time, I'm going to choose SQL CDC as my source because all my concession transactions, the inventory levels are being managed in Azure SQL. I don't need to change that. So I'm going to grab the SQL, the CDC events from there, from all the tables. And then I'm going to make an important choice here. I'm going to use Delta Flow, which is a public preview feature, to quickly convert that into an analytics-ready form and send it to an event house. So I'm going to do that, move forward, name the schema registry where this is going to be stored, all the schemas of the source tables, and go ahead and connect. And that's it. A few simple steps, and now you have CDC events without me having to know about Debezium or anything like that. The simple CDC events are flowing into an event stream and are going to go into a destination of my choice. In this case, I'm going to go ahead and put it in an event house. I'm going to say that for every single source table, use that schema to create the tables on in event house. And I want separate tables for all the different schemas. I'm going to go ahead and make a few other choices, just the payload and not the metadata, things like that. And I go ahead and publish the event stream. And within seconds, if you go to the event house, you will see all the different tables that I had. There are about 6 or 7 tables. They all get created. The initial snapshot replication starts to happen. And now your data from your SQL databases are available now. The changes are available now in your event house. And you can build any sort of applications that Anshul is actually going to talk about. You can build those on event house. So I'm done with the first setup, right? But now what I want to do is actually go ahead and check my inventory and be very quick to realize when inventory in a particular concession stand needs to be replenished. So I'm going to go ahead and use Spark and some sprinkling of AI in this. So I'm going to open a notebook. I'm going to connect it to an event stream, my concession event stream that I just created. And I'm going to say read with Spark. The system automatically generates a lot of code for you, all the boilerplate code of setting up the connection and start reading from it. And in this particular case right now, it's to start, I'm going to output to an event stream, to a console. But now I'm going to write the code. A lot of it can be generated by AI. And I'm going to create a prompt based on the data of the inventory levels that I also got. And I'm going to go ahead and call generate response to actually get the prompt from AI. Once I have that, I'm just going to publish a new thing in Fabric for business events. So very simple. My Spark job is now actually publishing business events to Fabric. Now, where do I go see it? I'm going to go back to Real-Time Hub. I see that the business event is there. I open it, and I can already see trends. But I want to take action, right? Dashboard is one thing. I want to take action. So every time there is a replenish concession event happens, I'm going to say, get an event, and here you see a sample. The AI is saying that, hey, you've got to queue up 200 units of hot dogs, very important, from one place in the stadium to another one. So I've got everything going, but it's important for me on game day to monitor it. And that's where monitoring for event hubs, for event stream actually comes into the picture here. With, again, just a few simple clicks, all detailed telemetry about and logs about event streams will now be part of your workspace monitoring databases. And you can create very simple dashboards to monitor very specific things that you might need for your operations. Let's quickly recap now what I showed you. So first, Delta Flow. We have had CDC connectors in event streams before, but now with Delta Flow, we make it even easier to process Debezium events. So quickly transform them. One of the challenges with dealing with CDC is, how do you adapt to schema changes that happen on the source side? So again, this is very easily taken care of by Delta Flow. Managing the hundreds of tables, if not thousands sometimes of tables on the source in your destination, again, taken care of by Delta Flow. And so you can spend your time actually building the application rather than worrying about all the different plumbing here. We are doing, CDC connectors work great with relational databases, but a lot of the data now is in Delta tables in Fabric as part of Mirror database. So we are introducing the public preview of a Delta change feed connector, which works great with Mirror databases and very soon with general Lakehouse Delta tables. And Spark structured streaming. Spark has a huge ecosystem, so we are now bringing that closer to event streams. So all the AI function calls, writing code in Python, and being able to leverage all the ecosystem open source libraries, that's now in your hands. Then Fabric business events. So again, it's not just about data processing and creating more data. It's about identifying business events and being able to publish them and act on them. And that's what you saw in portion of the demo there. And last but not the least, putting it all together and actually on game day, you need to constantly monitor what's happening in your system. And that's where event stream observability as part of workspace monitoring gives you those capabilities. So with that, I'm going to hand over to Anshul to give you more details on the analytics and action part.
All right. Thanks, Arindam. Hi, everyone. I'm Anshul Sharma. I'm a principal product manager in real-time intelligence team. And in this section, we'll focus on analyzing and acting on real-time data at scale and see it in action with hopefully a few exciting live demos. So as Arindam showed us, once you have data streaming in at high velocity and high granularity, the next challenge becomes is how do you ingest, analyze, and act on it? That's exactly where Event House comes in. Event House is a purpose-built store for event, log, and time series analytics designed to operate at petabyte scale with sub-second query performance. Now let me walk you through a typical end-to-end real-time analytics flow. On the left, you have connectors bringing data in. Typically, this data is then modeled in a medallion architecture in Event House with multi-tiered data staging. Data first lands in bronze layer, which is your raw ingestion layer. Then you use update policies, which are like lightweight transformation functions, automatically transforming and enriching the data as it comes and moving it into a silver layer. You can then further optimize using materialized views by deduplicating the data, by creating aggregation over it so that your reports can work on top of it. For the query part, you can use KQL for deep analytics or SQL for familiarity, depending on your workflow. Now, on the output side, this data powers real-time dashboards and Power BI reports for monitoring and reporting needs. And importantly, everything as in Fabric is in one lake. All the data is in one lake. It isn't siloed. It's fully integrated across your broader data estate. Now, where these capabilities become really, really powerful is by adding an intelligence layer on top. So now, once you have data streaming in, you can define rules, create alerts with Activator, even run anomaly detection, and build ontology that maps your business context onto your data. And then ultimately, you can have agents like operation agent and data agents in Fabric that act on your behalf, enabling AI-driven automation and real-time decisioning directly on top of your streaming data. Now, all these analytical capabilities are powered by EventHouse, which is a true multimodal analytics platform. At its core, it's designed for diverse schema-less data. You can inject text, JSON, metrics, time series data. That means you don't have to pre-model or force your data into rigid structure before you start getting value out of it. Now, this becomes especially critical when you are dealing with high granularity data across both time and space, such as logs, telemetry, user actions, or even IoT signals coming from your devices, right? Where the shape of the data typically is constantly evolving. Now, once this data is in, you're not limited to how you analyze it. You can seamlessly move across time series analysis, let's say for decomposition, prediction, anomaly detection, text and JSON searches, relational queries, and also sequence analysis and geospatial insights. And not just that, you can run like vector similarity searches for AI-driven RAG scenarios. Now, when you need like deeper analytics, you can directly use Python code without moving data out of the system. So the key idea is this, like EventHouse gives you one engine that handles diverse data and diverse analytics patterns at scale and real time. Now, let's look at these capabilities in a demo. We will analyze few petabytes of data in real time and directly show you some of these capabilities. Now I'm in a Fabric portal. What you see on screen is my KQL query set, which is attached to one of the event houses that I have. In this event house, I have one of the table. We are going to start by counting the number of rows that it has. If I run this query, you can see at this point, this table is holding close to 378 trillion records. That's huge. Now let's look at all the data that's coming in the last 1 hour. So if I run this query, this time chart shows us like every minute, approximately 13.5 to 14 billion new records are being added. So that's immense processing that's happening in real time. Now this is how you use KQL, but you can also use SQL to run similar insights, right? This is an example of a SQL query. Now let's change gears and let's take a hypothetical scenario that you're part of a GitHub team responsible for understanding user scenarios like user usage, like platform health, and so on. So I have live GitHub events coming in for all the developer actions that are being taken on GitHub, like pull, push request. I have like plugged it into an event stream, which is flowing the data into an event house live. And if I run a count out of this table, you can see this table has close to 3.6 billion rows. If we look at what are the type of events that are available for us right now, there are close to like few events like push event, create event, based on what developers are doing on the platform right now. Now let's look at the shape of the data. This data is a combination of structure as well as semi-structure. You see I have few fields which hold a bunch of JSON key value pairs. Now what is interesting is I can expand the JSON and retrieve the values out of it just by using KQL. So in this case, I'm looking at the display name of a particular user and translating it into a fixed column. And now I can start analyzing usage of a specific user, right? What they are doing, understand how they operate, and so on. Just to make it a bit more interesting, if you're responsible for forecasting the capacity of GitHub usage, you can use inbuilt forecasting function, which tells you what the pattern would look like in future based on existing data. Pretty powerful capabilities. Now, in some cases, you might want to have certain conditional queries, such as looking at certain events based on certain conditions, and not just execute ad hoc queries, but get alerted when they happen. So you can create alerts using activator on top and which allows you to send Teams messages or even trigger custom workflows, invoke notebooks, and so on. Now, lastly, if you don't like writing queries, you can use Copilot, which allows you to ask natural language questions and outputs KQL. This is also a great way to ramp up on learning KQL, and you can get insights out of it purely using natural language. Now, I know some of you might be thinking that, hey, this is all great, but it's 2026 and my agents are doing most of the job for me. What do you have for them? So the question shifts from how do I analyze my data to how do you actually empower these agents? Now, this is where MCP and skills come in. With real-time intelligence, we have Event House MCP, where agents can directly ask questions over live data and get instant insights. We also have MCP enable other items like Activator, where you can define rules and alerts all in natural language. And lastly, we offer Fabric Skills. Now, this Fabric Skills gives agents reusable capabilities and domain knowledge on how to interact with real-time intelligence items by connecting to tools like GitHub CLI and Claude Code. So instead of just querying data, your agents can now reason, act, detect all in real time. Let's look at this in action. Now, in the second demo, I would try to create an end-to-end real-time analytics flow by ingesting some data and as well as analyzing it all using GitHub Copilot CLI. So I'm in GitHub Copilot CLI right now, and I have installed Fabric Skills. So let's start by listing all the skills that I have available to me. So when I do that, you can see I have few skills available, including Event House, Event Stream Authoring, and Consumption skills, which we can use to further build our flows. Now let's give it a prompt saying create a new Event House, build a medallion architecture with all the things that we just learned, and give some interesting insights to us. Now I'm going to give it appropriate permission so it can start executing. And you can see the agent is able to leverage one of the authoring skills that exist. And now what it is trying to do is it will use it to learn how to create an event house and then start executing. Now it's trying to log in based on my credential and it's creating an event house for us. Let's give it a second or two. Yeah, it created an event house. Now it's trying to find the URI of the KQLDB, which is what we will use to interact with it and create a schema. Now, once it found the URI, now it's starting to execute the schema, the medallion architecture that we talked about, including all the 3 layers, update policies, materialize views, and so on. So it's creating KQL. Hopefully the LLM gods are with us while this happens. And there you go. Okay. So it was able to deploy the schema, and now it's trying to ingest some of the data. So this is part of the skill where we have told it to, hey, ingest the data and verify after creating any of the stuff that we ask you to, right? So now it's ingesting data just to ensure that our flow has been created as expected. So it's able to do that. And now it is giving us a nice summary of what was built. So you can see it created 3 layers. It created the transformation function, views, and so on. But let's just not trust the agent. Let's go in the UX and actually verify all of the things that it did. Now I'm in the Event House UX. This is my database that was created by the agent. I'm going to move to an entity diagram view. Now, entity diagram provides us a nice visual representation of the schema that exists in my database. And you can see, right, it is showing us that there are 3 layers that are created. If I click on the ingestion view, I can see that the data is flowing in as expected. We can also quickly verify the data that's coming in by clicking on the data preview. So it looks like everything was set up correctly. Now at this point, we can start writing queries. But hey, we said it's an agent first analytics. So why not ask our agent to do that? So Event House comes up with that remote MCP URL, which you can see here. Every Event House endpoint comes with that. So we can copy this, move back to the GitHub CLI, and continue our analysis there. So what I'm going to do next is add the MCP that we just got from Event House. And I'm going to select an HTTP or remote MCP and provide the URL that we just copied. Just keep the default settings as is. Now it's asking us to authenticate. Once it is done, our MCP is set. Now let's kind of look at what are the tools that this MCP provides. So it provides us a bunch of tools like execute query, get schema, and so on, which will help us agent interact with event house. Now let's give it a weak prompt saying share some interesting insights from my data that I just created and use the MCP that we configured. Now hopefully with this prompt, the agent is going to use the tools that exist and give us some interesting insights. So it's leveraging some tools, and you can see it quickly executed 5-6 different queries, read the data out of it, and now it's kind of giving us what the data looks like, what's the shape of the data, and things like that. This is pretty cool. Now, not just that, it's also suggesting some of the follow-ups, such as we can run advanced anomaly detection functions, and so on. So just to recap, what we did is, using MCP and real-time intelligence skills, we created an end-to-end flow, all using GitHub CLI, starting from creation of items, ingestion of data, as well as analyzing it with MCP, all via an agentic way using CLIs. Now, the same analysis capabilities you saw with MCP are also available in our Copilot experiences, right, where insights and visualizations are generated directly for you. Now, this is especially powerful for business users or anyone who prefers a web-based, low-friction interface. So whether you're building automated workflows with agents or interactively exploring data through Copilot, you're operating on a shared foundation of analytics capabilities that we expose. So the same tools and capabilities are accessible to both agents and humans, no matter how you choose to use it. With that, now I'd like to hand it over to Tessa to walk us through the final section.
Great. Thank you so much, Anshul and Arindam, for really showing us some of those end-to-end pieces from ingestion all the way through to analyze, act, and starting some of the AI capabilities that we have. And I'm going to take it a little bit further on the AI and then close us out. And you could see right on the screen, we've heard from multiple customers, there really is no AI without RTI. Now, what does that really mean? It means that all of this, time series, time sensitive, relevant, fresh data at this high volume, high granularity is really necessary in order to power and build these accurate and useful AI solutions, such as the ones you just saw Anshul demonstrate as well. And of course, being a build and focusing on their developers, you saw the different capabilities that we have kind of more geared towards our technical audiences. But just as Anshul was alluding to near the end, we really wanted to ensure that these capabilities are available to users of all different skills and capabilities. And so the next couple of scenarios I'm going to show in the final demo is actually a bit more UI focused and showing how you have this deep power, technical power and capabilities of all of these different tools in the toolbox we mentioned, but they're available to users of all different of skills. So the first one I'm going to mention is Anomaly Detector. This is a public preview capability that makes it very easy to leverage that streaming data that you saw Arindam bring in and store into the event house capabilities that you saw from Anshul. And with just a couple clicks, you're able to actually configure the right anomaly detector model for your specific data. You don't have to be a data scientist to leverage this. And then very quickly, you can actually publish and emit those events for the rest of the organization to subscribe to. So you'll see that in a demo shortly. And where the power really comes in is when we look at our operations agent capability. Now, we're very excited to announce that this is generally available. And what it allows you to do is take all of these pieces from the observing, the analyzing, the deciding and acting, and actually get this loop running autonomously. And you have as if you have a new member of your team, a virtual team member in your operations team that can really do all of these different stages, reason and understand, and actually act to help the organization move really at the speed of the business. So with that, let me just jump in and show it running, and so you can see the different capabilities that we have. And we're actually going to start in the anomaly detector experience. And you can see here, this UI is really just asking me to, choose which table and which field that I want to be monitoring for those anomalies. And just by connecting that data, it's actually going to analyze the particular data that I've provided and determine which model out of the out-of-box models that we have are best suited based off of, the seasonality, the pattern that exists within the data. And again, I'm not a data scientist, but you can see here it has the different models that are available. It tries to explain them in very user-friendly terms. And because I can actually see my data on the left-hand side, and I can see those anomalies that are being detected based off of the different models that I choose, I have higher confidence and I have better understanding of what it's actually doing with the system and helping me have that confidence that this is the right model for my system. It's going to actually tell me where the anomalies are, and I can publish it directly into the organization. Now that it's publishing and running, so as new data comes in, new anomalies are going to be detected. I can go back to the real-time hub, as Arinda mentioned, that central place for all of your streaming and event data, and I can actually subscribe and create a rule directly on those events that my anomaly detector is emitting. I can choose which fields I'm looking for. I can maybe even filter down to a specific set of the events. Maybe I don't want to, alert for all of the different pieces that are coming in. And just like that, I have a new alert ready and listening for any new anomalies that I can share across my organization. And as I mentioned, we're going to take it even further with the operations agent capability. We're very excited to be releasing this more broadly available. You go directly into Fabric and you can start by creating a new operations agent. And what it's going to do is it's going to load the configuration. Once again, you can see very user-friendly. On the left-hand side, I'm going to provide natural language to onboard my agent as if it's a new team member. I'm going to give it business goals. I'm going to give it specific instructions. And we also want to connect it back to the data. But we don't want to just connect it to the raw data. We want to actually leverage the new semantics that comes through in our ontology item. If you haven't heard about the ontology item, please do go check out the Fabric IQ session that's also being recorded. But by connecting it to this item, what I'm able to do is understand all of that business context, the entities directly out of box, and even actions that this agent can take. So now that I've moved ahead, I've configured the agent. You can see all of this information on the left-hand side. All I have to do is save and actually generate the playbook. And what a playbook means for an agent is really its understanding of all this information, of the data, of what it's trying to accomplish, and what actions it can take. So very quickly, you can see this playbook is generated. It's telling me back what terms it understands, so what entities. It tells me the rules, what it's looking for, and what it's going to do about it. And just like that, I can publish the agent directly into where our team works, which is in Microsoft Teams. And you can see it's already running 24/7. And as soon as it detects something that matches one of those conditions, it's going to alert the team. It's going to tell you what it's found. It's going to have that data information directly there. It's going to recommend an action and even give you an option to investigate further and do a bit more root cause analysis. So in this case, I'm going to choose that option. And with that root cause analysis gives me even more insight into what it identified and gives me more confidence in actually the action that it's recommending we're going to take. And just like that, from the same experience, I can confirm I want to take the action, confirm the parameters, and actually have the agent go and update the system. And any of these capabilities, of course, you want to be able to monitor and understand what's going on. We have a rich set of capabilities for understanding the activity, understanding what's running, what's pending, being able to actually go into a particular activity and understand what rule it was looking for, what query it executed, what decision it made. All of this information, once again, to give me that high confidence about the system and how it's running. So I know this was a lot of content between myself, Arindam, Anshul. We really tried to give you kind of a full end-to-end picture of real-time intelligence in Microsoft Fabric, from our streaming, analysis, modeling, visualizations, and acting experiences. And then just leveraging, the common theme you saw around those stadium operations. You can kind of see how all of these different pieces work together to build an entire solution to help run any business. But of course, in this case, you saw some of the highlights around that stadium operations. But whether it is, stadium operations or, operational reporting, connected assets, having that kind of command center for everything, real-time intelligence really does unlock a wide range of scenarios and capabilities, leveraging many of the different pieces that you saw today, existing and some of the new announcements that we have. So if you haven't tried it out yet, please do go take a look. And when we look at that unified intelligence platform for AI, you really see how all of these different pieces layer on top of each other to essentially provide you that full system to really build out, whether it's your human teams or your agent teams, to really ensure that they improve the business in time. And so there's so many different announcements that we've been making, over the last few months and even at Build and going forward. Definitely keep a close eye on our release planner and the release notes because Fabric is releasing every single week and we have so many different capabilities coming through. But quickly, some highlights, the Operations Agent GA, you heard more about the business events, you saw connectors across event stream, new capabilities with Activator, including new actions. So just a wide set of features and much, much more to come. If you're not yet familiar with RTI, and I also mentioned a little bit IQ, definitely leverage our hands-on learnings that we provide with the workshops in many different countries. Leverage these links and these QR codes to go sign up. They're all free and available for you to try out today. And when in doubt, we have so much different information, whether it's, again, those hands-on labs, you can engage in the forums or the communities, using our documentation or following, again, the release plan or the different LinkedIn updates we do. We have so much information out there, and we're really excited for you to learn more about real-time intelligence, for you to try real-time intelligence, and to give feedback, and we can keep building this solution together. So with that, I will say thank you so much for joining us, and enjoy the rest of your build.